Builders broke ground on the Empire State Building in March 1930. By May 1931, just 410 days later, it was open. 102 stories, 1,250 feet, ahead of schedule. Today, a tower of comparable height takes 5 to 7 years. We have supercomputers, drone surveys, 3D modeling, tools those crews couldn't have imagined. And yet, skyscrapers in the 1930s went up fast than anything we build now. But this isn't simply a story about lost efficiency. The real question is what that speed demanded from the thousands of men who made it possible, and why we deliberately chose to never build that way again. A single question stands out. How did a skyscraper like the Empire State Building rise so quickly, when today's towers, built with lasers and laptops, crawl for years? The contradiction is hard to ignore. In the 1930s, workers built higher, faster, and seemingly with fewer obstacles, even though their tools were basic and their safety measures almost non-existent. Construction sites buzzed with activity from dawn until dusk, with thousands of laborers crowded onto a single project. There were no digital blueprints, no automated cranes, no software managing the chaos. Yet somehow steel frames shot skyward at a pace that still defies belief. The answer lies in a mix of urgency, organization, and the stark realities of the era. Developers and contractors could marshal armies of skilled workers, many desperate for a paycheck during the Great Depression. Laborers worked 12-hour shifts, 6 days a week. Decisions flowed from a single authority, not through layers of review. Every phase, design, permitting, material delivery, steel erection, happened in tight succession, often overlapping. Steel beams rolled off trains and onto barges, arriving at the site just in time to be hoisted into place. Specialized crews like the four-man rivet gangs kept the rhythm relentless. The Empire State Building's 410-day timeline wasn't a fluke. It was the result of a system designed to move at breakneck speed. But that speed came at a price. Safety nets were rare. Workers balanced on narrow beams hundreds of feet above the street, often without harnesses. Regulations were minimal, and oversight was limited to basic inspections. The human cost was real. Injuries and fatalities were accepted as part of the job. Today, the process is slower, but for reasons that reflect a different set of values. Modern skyscrapers are shaped by rules that protect workers, communities, and the environment. Delays are built into the system, not out of inefficiency, but from a deliberate choice to prioritize safety, accountability, and quality over raw speed. The paradox isn't about lost skill or ambition. It's about what society is willing to risk and what it refuses to sacrifice. 17 March 1930. The first shovel broke ground at 5th Avenue and 34th Street. 410 days later, on May 1, 1931, the Empire State Building opened its doors. This timeline wasn't a legend or a marketing flourish. It was documented in city records, construction diaries, and front-page headlines. The entire project, from empty lot to finished skyscraper, took just over 13 months. Within that window, the steel frame itself climbed skyward in 365 days, a pace that remains unmatched for a building of its size. At the center of this breakneck schedule stood John Jacob Raskob, the financier whose vision for the project was simple: build higher and build faster than anyone before. Raskob's approach was all about compression. Design work started while demolition crews were still clearing the site. As soon as the foundation was poured, steel orders were dispatched to Pittsburgh. U.S. Steel's mills cut and drilled beams to exacting specifications, then shipped them by rail and barge to Manhattan, often arriving the same day they were needed. There was no room for hesitation. Every phase overlapped, and every trade worked in tight succession. This wasn't just an engineering feat, it was a logistical one. The schedule was tracked in daily logs, with milestones like the placement of the first steel column on May 1, 1930, the topping out of the 80th floor on January 7, 1931, and the final steel beam set in April. By the time President Herbert Hoover pressed the button to light up the building in Washington, the team had delivered a 102-story tower in less time than it takes most modern projects to clear their first round of permits. The raw numbers are hard to ignore. 410 days from start to finish. 365 days from the first steel to the last. No modern skyscraper of comparable height has come close. The Empire State Building's timeline stands not just as a statistic, but as a challenge to everything we assume about progress and efficiency in construction. It's a headline fact that demands an explanation, and it's the foundation for understanding why speed once came so easily and why it's so elusive now. At the heart of the Empire State Building's rapid ascent was the sheer density of human labor packed onto a single city block. Daily logs from winter 1930 show a peak of 3,427 workers on site, men from all over New York and beyond, many driven by the desperation of the Great Depression. The project ran on a relentless schedule, 2 overlapping 12-hour shifts, 6 days a week, with crews swapping out at dawn and dusk. The ground never sat quiet. By mid-December, the site was a hive of activity, with electricians, masons, steelworkers, and finishers all working in tight quarters, sometimes only feet apart. This wasn't an abstract workforce. It was a coordinated surge, managed with military precision. Jimmy O'Brien, a foreman known for his knack for mobilizing crews, kept the operation running like clockwork. Orders flowed down a single chain of command, with every trade answering to a central superintendent. There were no layers of subcontractors or endless meetings. When a decision needed to be made, it moved from the office to the steel beams in minutes, not days. The numbers tell their own story. On December 15, 1930, the official headcount reached 3,427, a figure unmatched by any modern skyscraper project. Rivet gangs worked side by side with concrete teams, each group specialized and practiced, turning out floor after floor at a pace that bordered on industrial choreography. The steel frame rose at an average of more than 1 story per day, with crews driving thousands of rivets in a single shift. Every worker's job was tightly defined, and the rhythm never let up. This flood of manpower was possible only because of the economic crisis of the era. Unemployment in New York hovered above 20%, and jobs on the Empire State site were fiercely sought after, even with the danger. The human horsepower was staggering, but so was the risk. There were no hard hats, no harnesses, and few safety nets. Injuries and even deaths were accepted as the price of speed. The labor surge made the impossible timeline a reality, but it also exposed the raw bargain at the core of the 1930s construction: build fast, accept the cost, and keep moving up. Permits for a skyscraper today often fill entire binders, each one a record of months, sometimes years, of review, revision, and negotiation. In 1930, the process was almost unrecognizable by modern standards. The Empire State Building needed just a single building permit from the city's Department of Buildings. That one document, signed off by a single official, cleared the way for excavation, steelwork, and everything that followed. There were no environmental hearings, no community board reviews, and no state or federal sign-offs. Zoning compliance was a matter of checking the building's setbacks against the 1916 law. Once the plans passed that basic hurdle, the rest moved with astonishing speed. Memos and letters from the time show how decisions that might now require weeks of back and forth were handled in hours. If a change was needed in the design or a delivery schedule had to be adjusted, a foreman could walk into the site office, get a signature, and return to work with the new instructions in hand. The entire chain of command was compressed. Instead of dozens of agencies and consultants, there was a single point of authority, one person whose approval could keep the project moving. On the Empire State job, this gatekeeper role was critical. Every request, from steel delivery to overtime shifts, passed through the same desk. Delays were rare, and accountability was direct. This centralized oversight created a kind of workflow logic that is almost impossible to replicate today. With one permit and one decision maker, the builders could coordinate labor, materials, and scheduling as a single unified system. The simplicity of the process meant that thousands of workers and tons of steel could be marshaled without waiting for a cascade of permissions. The result was a project that moved at a pace modern contractors can only imagine, not because of better tools or technology, but because the path from idea to action was almost frictionless. Steelwork on the Empire State Building didn't just move quickly. It moved with a kind of calculated chaos that modern builders rarely attempt. John O'Donnell, the project's construction manager, was the architect behind a system that turned the site into a living assembly line. Instead of waiting for one floor to finish before starting the next, his crews worked in parallel, leapfrogging each other up the tower. This method, known on site as the jump line, allowed teams to work on multiple floors at the same time. While one group installed steel beams on the 30th floor, another was already laying concrete on the 25th floor, and a third was wiring electrical systems 10 floors below. The result was a construction rhythm that never paused. Every task was broken down and sequenced so that trades could follow each other in rapid succession. O'Donnell's daily logs show how the steel frame advanced at a rate of 4.5 floors per week, more than one floor every 2 days. That pace was only possible because material delivery was timed to the hour, not the day. Barges carrying steel from Pittsburgh would dock at the Hudson River piers in the morning. By afternoon, those same beams were being riveted into place hundreds of feet above the street. There was no stockpiling, no waiting for missing parts. The workflow was so tightly managed that delays in one trade could ripple through the entire schedule, so O'Donnell kept a close watch, shifting crews and reassigning tasks as needed to keep the jump line moving. This overlapping system was both bold and risky. With so many teams working on different floors at once, coordination had to be exact. A missed delivery or a scheduling slip could bring the whole operation to a halt. But under O'Donnell's direction, the system held. The Empire State Building's frame rose at a speed that has never been matched for a building of its size. The jump line wasn't just a trick of logistics. It was the engine that powered the project's legendary timeline. Steel for the Empire State Building moved with a precision that feels almost impossible today. At the heart of this system was a direct line from U.S. Steel's Homestead Mill in Pittsburgh straight to the Manhattan job site. Each beam and girder was cut, drilled, and labeled at the mill, then loaded onto rail cars bound for New York. The timing was exact. Steel often left Homestead in the early morning and arrived at Hudson River piers within hours. There it was transferred onto barges for the final short trip downriver. Unloading was a race against the clock. Workers could clear an entire barge in less than 30 minutes, hustling each piece directly to the foot of the rising tower. This just-in-time delivery wasn't a luxury. It was a necessity. Manhattan offered no space for stockpiles. Every piece of steel needed to arrive not a day early or late, but at the precise moment crews were ready to hoist it skyward. The site's material flow was tracked down to the hour with a dedicated mill liaison stationed in the site office. His job was to coordinate with the Pittsburgh plant, signal for shipments, and resolve any snags before they slowed the jump line. If a single delivery missed its slot, the entire assembly line on the steel frame could grind to a halt. The result was a choreography that few modern projects can match. As soon as a barge docked, teams of iron workers swung into action, guiding beams onto waiting derricks. In some cases, steel that touched the dock in the morning was riveted into place by lunchtime. This relentless pace, powered by human coordination and a tightly managed supply chain, fed the rhythm of the rivet gangs above. The building's vertical progress depended as much on the invisible web of rail schedules and barge crews as it did on the men working high above the city streets. High above the city, the rhythm of the rivet gang set the pace for the Empire State Building's ascent. Each shift, crews drove more than 6,000 rivets into place, one every 7 seconds, hour after hour, day after day. The process was a kind of industrial choreography, practiced until it became second nature. At the heart of it all stood foremen like Mike Sullivan, leading teams with a precision that left little room for error or hesitation. A four-man gang worked as a single unit. The heater stood by a coal-fired forge, plucking glowing rivets with tongs and tossing them through the air, sometimes 30, sometimes 90 feet, across yawning gaps between beams. The catcher waited, eyes locked on the red-hot projectile, snatching it from the air with a metal bucket and dropping it into a waiting hole. The bucker-up braced himself, holding the rivet's head steady against the steel, while the riveter fired up his pneumatic hammer, flattening the far end in a burst of heat and noise. Each connection was a test of timing, trust, and nerves. Miss the catch, and a rivet could sail off into the street below, or worse, burn a hole through a worker's glove. Sullivan's crew moved with a speed that seemed impossible. Oral histories recall the clang of hammers, echoing in a relentless, syncopated beat, the air thick with smoke and the smell of scorched metal. The gangs worked side by side, their arcs of thrown rivets tracing lines through the open frame. Every floor depended on their pace. If the rivet gang slowed, the whole project slowed. If they kept time, the building climbed. This relentless drive, powered by skill and sheer will, pushed the Empire State Building skyward at a rate modern projects have never matched. But the same urgency that fueled this rhythm also meant risk was ever present, a reality that shaped both the legend and the cost of building fast. The Empire State Building's schedule wasn't just the product of fast hands or clever logistics. It was also the result of a regulatory vacuum that would be unthinkable today. In 1930, the city's Department of Buildings issued a single permit for the entire project. That document, signed by one commissioner, gave developers the green light to dig, pour, and build, all without facing a cascade of outside reviews. There was no uniform land use review procedure, no state Environmental Quality Review Act, no public hearings or environmental impact statements. The only real constraint was the 1916 zoning law, which shaped the building's setbacks but didn't slow the process. Once the plans fit the code, the rest was left to the discretion of the project's leadership. This absence of oversight cut months, even years, out of the timeline. Contractors didn't have to submit stacks of paperwork or wait for sign-offs from multiple agencies. If a change was needed, a new delivery schedule, a revised floor plate, an overtime request, it could be handled in a single meeting, sometimes with just a signature from the commissioner or the superintendent on site. The city's role was limited to basic safety checks and structural inspections, usually scheduled around the construction team's needs. There were no stop work orders for noise, dust, or traffic. No environmental review delayed the start. No community board could stall the project with objections. This freedom allowed builders to move with a speed that's impossible under modern rules. Today, projects must navigate a maze of approvals. ULURP alone can take 7 months, and SEQRA adds another year or more for environmental review. Each step is designed to protect workers, neighbors, and the city itself, but it comes at the cost of time. In the 1930s, the lack of these protections meant the Empire State Building could rise almost as fast as its crews could work. The trade-off was clear: unprecedented speed, but with minimal checks on safety, environmental impact, or public input. That's the bargain that made the 410-day miracle possible, and it's a bargain modern society has chosen to leave behind. Tom Collins, a site safety inspector who spent years watching crews scale the city's tallest frames, offered a blunt warning in a 1931 interview. No building rises this fast without a cost. On the Empire State job, that cost was measured in lives. 5 workers died before the tower's lights flickered on, 2 from falls, 3 from heart attacks. These numbers, recorded in the project's daily incident logs and reported in the city press, were seen at the time as almost miraculous, given the scale and pace of the work. But behind the statistics stood a simple fact: safety was left to chance. Personal protective equipment was nearly non-existent. Hard hats wouldn't become standard until years later. Harnesses and fall arrest lines were rare. Most men worked in street clothes, gripping steel with bare hands, sometimes hundreds of feet above Fifth Avenue. Collins described mornings where rivet gangs, still stiff from the cold, would edge out along beams slick with frost, nothing but balance and habit keeping them from disaster. If a rivet missed its mark or a boot slipped, there was no net waiting below. The city's building code required little more than a cursory inspection and a handshake from the foreman. The economic logic was clear. With thousands of men lining up for work each morning, the pressure to keep the schedule moving outweighed any pause for safety. Every delay meant lost wages, not just for owners, but for workers desperate to hold on to a job. Collins's warnings were rarely heeded. The expectation was that men would accept the risk, that a fatal fall or sudden collapse was simply part of the bargain. In the public imagination, the Empire State Building's speed became a symbol of progress and grit. But for those on the beams, it was a daily gamble. The project's official record, 5 dead, countless injured, was considered a point of pride at the time. Today, it stands as a stark reminder of the ethical trade-offs that made such speed possible. Unemployment in the United States surged to nearly 25% during the early 1930s, leaving millions out of work and fueling an unprecedented surplus of skilled and unskilled labor. Dr. Eleanor Jacobs, an economic historian, points to payroll records from the Empire State Building and similar projects to illustrate the depth of the labor pool. In New York City alone, more than 1 in 5 adults found themselves jobless by 1930. For those lucky enough to land a spot on a skyscraper crew, the pay was modest, about $1.75 for a 10-hour day, sometimes less for helpers and laborers. Yet even at these wages, lines of men stretched down city blocks, hoping for a chance to join the work. This labor glut had a direct effect on the speed and scale of construction. Contractors could hire thousands of workers at a moment's notice, filling every shift and every trade with men eager to work long hours in dangerous conditions. The Empire State Building's daily logs show a workforce that swelled past 3,400 at its peak, with iron workers, bricklayers, masons, carpenters, and electricians packed onto the site. The abundance of labor allowed for overlapping tasks, quick crew changes, and relentless progress up the frame. If someone was injured or unable to keep up, there was always another man waiting to take his place. The economic desperation of the era also shaped the balance of power on site. Developers and contractors held the upper hand, setting schedules and safety expectations with little pushback. Unions existed, but their bargaining power was undercut by the sheer volume of unemployed workers willing to accept any terms. Jacobs's research highlights how this imbalance made the breakneck pace possible. Every day lost to delay risked losing a paycheck, and for many, that paycheck meant the difference between feeding a family or going hungry. The labor surplus of the Depression era was both a resource and a warning. It enabled feats of construction that still astonish, but it did so by leveraging human vulnerability. The contrast with today's regulated, safety-focused building environment is stark. Modern delays are not just the price of red tape. They are the outcome of a society that no longer treats labor as endlessly replaceable. The speed of the 1930s was real, but so was its cost. A modern skyscraper in New York cannot break ground until it has cleared a labyrinth of approvals. The Uniform Land Use Review Procedure, or ULURP, stretches for 7 months at minimum. It starts with an application, then moves through community board hearings, borough president recommendations, and a city planning commission vote. Each stage is fixed on a public calendar and must allow for comment, revision, and reconsideration. Even after a project passes ULURP, The State Environmental Quality Review Act, SEQRA, adds another year or more. This process demands a full environmental impact statement, public hearings, and mitigation plans for everything from noise to shadow impact to air quality. The paperwork alone can fill entire rooms. Architectural renderings, shadow studies, traffic analyses, and legal notices, each reviewed by multiple city and state agencies. Laura Chen, a project manager with 2 decades of experience in Manhattan high-rise construction, describes the process as a marathon of forms and meetings. She keeps a timeline pinned above her desk: ULURP 7 months, SEQRA 12 to 18 months, building permit review 4 to 6 months. In total, 3 years can pass before a single shovel touches the dirt. Every change in design or use, adding a loading dock, shifting a facade, triggers another round of review. Even small adjustments can add weeks or months. This is not just red tape for its own sake. Each layer was created in response to past abuses, unsafe buildings, environmental damage, neighborhoods upended without warning. Today's approval maze is designed to protect the public, but it comes at the cost of time. In the 1930s, the Empire State Building needed 1 permit and a zoning check. Now, a comparable tower faces a gauntlet of oversight that can take longer than the entire construction of its predecessor. The modern skyscraper's slow start is not a sign of lost ambition, but a deliberate choice to build with more voices at the table and more safeguards in place. Alex Patel, a construction technology analyst, points to a strange reality. Even with digital models and cloud-based coordination, modern skyscrapers rarely match the pace of their 1930s ancestors. On paper, building information modeling, known as BIM, should be the ultimate accelerator. It allows architects, engineers, and contractors to work on the same digital plans, catching design clashes before they happen on site. But the promise of seamless coordination often runs into the friction of real-world complexity. A single BIM model for a new high-rise can take 9 months to finalize, with each revision triggering rounds of review and approval. Instead of overlapping work, teams wait for digital sign-offs, each step measured and documented. Material logistics have also changed. In the Empire State era, steel left Pittsburgh in the morning and arrived at the Manhattan site just hours later. Today, steel for a New York tower might be fabricated in South Korea or China, then shipped across the ocean. The average lead time for custom steel frames is now 6 weeks, sometimes more if supply chains are strained. Every delay ripples through the schedule, and there's little room for improvisation when parts are halfway around the world. Patel explains that modern technology brings real advantages: precision, predictability, and fewer costly mistakes. But it also slows things down. Digital coordination means every change is tracked, every conflict resolved on screen before a single beam is set. The paradox is clear. Software and global supply chains make buildings safer and more sophisticated, but they also add layers of process that the Empire State's crew would never have imagined. The speed of the past was built on risk and urgency. The pace of today is shaped by caution, accountability, and a different set of values. Mark Rivera, a veteran safety manager, stands by the new pace of construction with a quiet conviction. 0 fatalities on a modern core build is not a statistical fluke. It's the outcome of hard-won protections and relentless oversight. Today's skyscraper sites are governed by strict shift caps, union contracts that limit overtime, and daily safety briefings. Rivera points to the difference these rules make. Workers head home each night, not to the hospital. Laborers now operate 8-hour shifts, 5 days a week, with mandatory breaks and protections against heat, cold, and exhaustion. The result is a work environment where accidents are rare, and families don't wait in fear for news from the site. Modern standards go beyond just physical safety. Energy codes have driven a 20% reduction in building energy use compared to towers from the last century. High-performance glass, advanced insulation, and smarter systems mean today's skyscrapers are cleaner and cheaper to run. Labor rights have shifted the balance too. Unions negotiate not just for pay, but for health care, training, and the right to refuse unsafe work. Rivera recalls the old stories, men clinging to beams without harnesses, no questions asked. Now, a worker can call a safety stop, and the entire site listens. The delays that frustrate owners and developers are, in Rivera's eyes, the dividends of progress. Each extra month on the schedule represents lives not lost, injuries avoided, and a city that's quieter, cleaner, and more just. The race to the top is no longer a gamble with human life. Instead, it's a process shaped by care, accountability, and the belief that a building's true value lies not just in how fast it climbs, but in how safely it stands. Today's skyscrapers rise more slowly, not from a lack of skill or ambition, but because society demands higher standards, fewer accidents, safer labor, and greater accountability. The Empire State Building's 410-day ascent stands as a marvel, but also as a measure of what was risked and sacrificed. We now build with more caution, valuing life and sustainability over speed. Sometimes, progress means choosing patience over spectacle. What would you choose? Let us know in the comments below.